Chapter 3 Pumps, Field Manual 5499. Hydraulic pumps convert mechanical energy from primary movers energy or electric motor and hydraulic pressure energy used to operate a actuator push. Pumps push on hydraulic fluid or grade fluid. Pump classification: all pumps grade fluid, they operate with a displacement principle. Fluid is taken in and displaced to another point. Pump the discharge liquid in a continuous flow with a non-positive displacement. Pumps the discharge liquid volumes of liquid separated by non-period non-discharge or positive displacement. Non-positive displacement pumps the volume liquid delivery with each cycle depends on resistant overflow offered to flow. The pump produces force of the liquid that constant to each of the particular speed of the pump. Resistant in discharge of the procedures produces a force opposite direction. Force is equal liquid in the state with the equilibrium does not follow. In the outlet of a non-displacement pump is completely closed. The discharge pressure will arrive at the maximum of the pump operating maximum speed. Pump will churn a liquid or produce a heat. Figure 3.1 shows the non-positive displacement pump. A water wheel picks up the fluid and moves it. Positive displacement pump with a pump at a different volume of liquid delivered in each cycle with the pump operation regardless of resistance, as long as the capacity of the power even the drive in the pump does not exceed the outlet with a completely closed. Even the unit driving a pump will stall or something will break. Therefore, a positive displacement pipe type pump requires pressure regulator, pressure relief device in the system. Figure 3.2, Figure 3.2, page 3.2 shows reciprocating pump positive displacement. Figure 3.3, page 32 shows with another positive displacement pump. The pump does not only creates flow but also back it up. Sealed case around the gear traps the fluid, holds it within it. Move the fluid flows to the other side. The seal against the back of the sealing of the position part of the displacement. Without the fluid could never overcome the resistance of the other parts of the system. Show with a non-positive displacement pump sealed with a positive displacement. See characteristics. There are three contracting characteristics in the operation pipe of the non-displacement pumps are followed. The non-displacement pumps provide a smooth, continuous flow of positive displacement. Have the pulse with each stroke. Each time the pumping chamber opens to outlet port, pressure can reduce positive non-positive pumps delivery. High outlet pressure can stop any output. Liquid simply recirculates inside of the pump, and the positive displacement per pump pressure affects the output only with the extent that it increases the internal leakage. Non-displacement placement pumps with inlet and outlets connected with a hydraulic cannot create vacuum sufficient with a self priming. They must be started with the inlet line full of liquid free of air. The positive displacement pump often self-priming started properly. Performance pumps are usually rated according to their volumetric output with the pressure of the volumetric output, delivery rate with the capacity amount of the liquid that can pump into the delivery of the outlet port per unit time, and the driven speed with usually gallons per minute or cubic inches per feet per minute. Because changes in pump to drive with the volumetric output pumps are sometimes rated according to the displacement amount of the liquid that can deliver the per cycle cubic inches per revolution pressure and the force per unit. As of 3.2 shows reciprocating type of the positive displacement pump 1, 2, and 3 outlet. Pressure is force and per unit area liquid usually expressed within PSI. Most of the pressure of the hydraulic system covered with the manuals created with the resistance of the flow, with the resistance usually caused with the restriction and obstruction of the path of the flow. Pressure developed in the system affect the volumetric output of the pump with the supply of the flow of the system. The pressure increase with the volumetric output, decrease with the drop in output caused for the increase with the internal leakage or slippage of the pump's outlet side over the inlet side. The slippage is measured in the pump efficiency, usually expressed in percent. Some pumps have a greater internal slippage than others. Some pumps are rated in terms of volumetric output with a given pressure. Figure 3 shows a positive displacement pump with the inlet low pressure and the pumping chambers, outlet pump and high pressure. Displacement over the amount of liquid transferred by the pump inlet over the outlet with one revolution of the tone. Rotary pump displacement with the cubic inches per revolution. In reciprocating pump, the cubic inches per cycle if the pump has more than one pumping chamber. The displacement equal to the displacement one chamber to multiple with the number of the chambers. The displacement is either fixed or variable. The fixed displacement pump, in this case, the degenerate gallons per minute output can be changed only by the varying drive speed. But the pump can be either the open center system with the pump output that has a free flow back of the reservoir with a normal neutral condition of the circuit. B, variable displacement pump with the pump of the pumping chamber soft with the B chain with the gallons per minute with the delivery with the B chain with the moving the displacement control with the changing with the drive with the SB with the doing both with the pump can be either the closed center system. The pump continue to operate against load in neutral condition. Slippage oil is oil leaking from the pressure outlet with the low pressure of the area back into the inlet with the drain pressure to allow the leaking oil to return into the inlet line or the reservoir. Of some of the slippage is designed to pumps lubricating purpose. For the slippage will increase the pressure and the pump begins to wear with the oil flow. For the given the oil, depends on the pressure of the drip of the internal leakage path of the shame as an orifice. Therefore, the pressure increases the more the flow that occur with the leakage path, the less than the outlet port. Any increase in the slippage and loss efficiency design. As most rotary hydraulic pump, figure 3.3, the design is such that the pumping characteristics increase the size of at the inlet and thereby creating a vacuum. The chamber that decrease inside of the outlet push fluid into the system. The vacuum of the inlet with the create with the pressure difference of the fluid will flow over the reservoir to the pump. However, in many systems, the inlet is charged and supercharged, that is positive pressure rather than a vacuum created with a pressurized reservoir ahead of the fluid above the inlet, or even low pressure charging pump. The essential with the hydraulic pump are low pressure inlet port, which carry fluid over the reservoir, high pressure outlet port connected with the pressure line, pumping chamber to carry the fluid for the inlet of the outlet port, mechanical means with activating the pump chamber. The pumps may be classified according specifically designed either to create the flow of liquid. Most hydraulic pumps are central figure rotary and reciprocating central figure pump. The pump generally is wherever the large volume of the flow with the required relatively low pressure connected in series with the feeding of the outlet of one of the pump into an inlet of another. Arrangement of the pump can be developed the flow against the high pressure with the central figure pump with the non-displacement pump of the two most common type of the volatile and the diffuser. Volatile pump, the figure 3.4, page 3.4. Pump has a circular pumping chamber with a central inlet port with a suction pipe at the outlet port with a rotating improper liquidity with a pumping chamber. The chamber between the casing with the center hole is volatile liquid enter the piston chamber through the center inlet or eye trap between the whirlwind improper blade with the central figure forces throws liquid outward with a high velocity and a contouring case directs with the moving liquid through the outlet port. Diffuser pumps figure 3.5, similar to volatile type diffuser pump, has series of stationary blades with a diffuser with the curve of the opposite direction of the whirling impeller. Blades of the diffuser reduce the velocity of the liquid, decrease the slippage, and increase the pump's ability to develop the flow against resistance. Rotary pump. In the positive displacement type of the pump, the rotary motion carries the liquid over the pump inlet with the outlet with the rotary pump, usually classified according to the type of the element that actually transmit liquid, the gear, vane, or piston type of rotary pump. 3.4 shows a volatile pump. Shows the outlet with the suction inlet pipe, the volatile pumping chamber, and the blade and eye. 3.5 shows the diffuser pump with the inlet and then the impeller and the diffuser and outlet. Reciprocating pump depends on the reciprocating motion of the transmit liquid with the pump the inlet to the outlet. Figure 3.2, page 3.2 shows the simplified reciprocating pump with the cylinder housed with the reciprocating piston. Figure 3.2 and then 1 and inlet valve with the figure 3.2.2 and outlet valve. Figure 3.2.3 direct fluid from the cylinder with the piston moved to the left of the partial vacuum create the draws the ball off the sheet valve of liquid to be drawn through the inlet valve of the cylinder. When the piston moved to the right of the wall, receive the close of the inlet valve out with the force of the flow and receive the ball allowing the fluid to be forced out of the cylinder through the outlet valve. 3.6 gear pumps. Gear pumps are external, internal, and lobe type. The external with the figure 3.6 show the operating principle with the external gear pipe with the consist of the driving gear enclosed with the closed fitting housing of the gear rotate with the opposite of the direction mesh point of the house between the inlet and outlet ports, both set with the teeth of the project with the outward with the center of the gears, the teeth of the two gears separated with a partial vacuum form with the draws liquid through with the inlet port with the chamber A with the liquid in chamber A is trapped between the teeth of the two gears housing it so that it would carry through the two separate paths of the chamber B with it as the teeth again mesh so they produce a force and drive liquid outlet port. Internal. Figure 3.7 show the internal gear with the pump of the teeth of one gear with the project outward, while with the teeth of the other gear project with the inward torque of the center of the pump. The one gear will stand on the inside of the other. The type of the gear rotate can be rotated suitably. Construct the companion gear. An external gear is directly attached with the drive shaft of the pump is placed in the center of the relationship with the internal gear with the two gears mesh of the one side of the pump chamber between the inlet and the discharge on the opposite side of the chamber. The crescent shape is the stand with the space between the two gears to provide the clearance tolerance. Figure 3.6 shows an external gear pump with the inlet port and the driving gears and then to the outlet port A and B. The rotation internal gear shaft causes the external gear to rotate until the two are meshed with everything with the chamber to rotate with the crescent, causing the liquid to be trapped with the gear space with the crescent liquid is carried from the inlet to the discharge, which forced out of the pump of the gear meshing when the liquid is carried away. 57 shows the internal gear pump oil drawn in here. 2. The constant withdrawal of the teeth from its teeth. 3. In the inner gear. The spaces between the teeth of the internal gear. 4 is carried in these spaces. Outer gear crescent seal. 5 to the point where the constant meshing of the two gears forces oil. 3.8 shows the inlet lube pump shows that a low pump shows the outlet and inlet. From the inside pump, with the pressure of the diminished liquid is full for the supply, so the side of the crescent separates with the internal and external of the gears determines the volume of the delivery of the pump. With the small crescent allows more volume of the liquid per revolution than a larger crescent. Lobe. Figure 3.8 shows the lobe pump of the difference with the other gear because even the lobed elements instead of the gear of the element drives all difference with the lobe pump. The gear pump with the one gear with the drive of the other. The lobe pump, both elements are driven through the suitable external gearing. 3.7 the vane type of the pump is a lot of rotor slitted to the drive shaft of the rotor between the closely fitted slide plate with the inside of the elliptical circular shaped ring with a polish hardened vane slide into the and out of the rotor slots and following with the ring contour of the central figure force pumping and chambered with the form between the succeeding veins carrying out from the inlet to the outlet with a partial with a vacuum is created with the inlet space between the veins and the oil size is squeezed out with the outlet with the pumping chamber size decreases because of the normal wear of the points of the vein pump with the vein tip of the ring surface of the vein ring with a specifically hardening ground of the vein pump that is only designed so the automatic wear of the compression point built in whereas the curve of the vein simply slide farther and outer of the rotor slot. Continuing to follow the ring contour of the efficiency remains high throughout the life of the pump. Characteristics. Displacement of the vane type pump that depends on the width of the ring with the rotor with the cam ring with the internal change of the ring with the design of the basic pump with the converts with several of the displacement balanced design. Vane pumps also fixed displacement. Unbalanced designs could build in either fixed or variable displacement pump with the vane pump that have good efficiency, durability, and operative with the clean system using it with the correct oil with the coverage with the low, medium, high pressure capacity, speed ranges, package size, relation to the output of the small vane pipe that is generally quiet with while wine is high in speeds. Unbalanced vane pipe of the unbalanced design, figure 3.9, cam ring shaped of the true circle, the differing central line from the rotor of the pump displacement that depends on how far of the rotor ring of the centric with the range of the true circle of the ring with the control of the applied with the very eccentricity, the varied displacement, the disadvantage of the unbalanced pressure of the outlet, effective begins with a small A with the rotor edge with impossible opposing side loads on the shaft. Thus, they are the limit of the pump size unless a very large carrying have heavy support are used. Balanced vane pipes and balanced design figure 310 for the pump at the station elliptical cam ring and the two sets for the internal pump of the pump chamber is formed between the two vanes twice for each for the rotation inlet and outlets 180 degrees back pressure against the edges of the rotor cancel each other without recent design improvement to allow with a high operating speed. The pressure of the made up with its pump must be universal and mobile equipment field. 3.9 show the unbalanced vane pump, show the shaft of the rotor and the vanes and the casing inlet and outlet. Double pumps, vane double pump, figure 311. Consists of the two separate pumping devices, each contained with only respective housing mount with a tandem driven with a common shaft. Each pump also have an inlet and outlet port, which may be combined with the value of the manifolds or pipe. The design variations are available. The both cartridges contained within one body, and additional pumps sometimes attached with the head end of the supply with auxiliary flow requirement to double in. Double pumps may be either provide fluid flow with the two separate circuits combined with the flow requirements. A single circuit with the combining pump delivers does not alter with the maximum pressure rating of either cartridge with the separate circuits or require separate pressure for the control to limit the maximum pressure in each circuit. Figure 312, page 38, show the installation of the double pump to give it the provide flow power for the operation. Some of the rapid advance for the feed. Figure C to B, figure circuit B to relief of the valve of control pumping operation. Circuit A, one relief valve on one unloading valve is used for the control pumping operation. Both the circuit with the deliveries of the pump cartridges are combined, but after passing through the valve, they are combined. Flow is direct to the four-way valve to the rest of the circuit. Alright, on circuit B, the upper relief valve of the vent of the circuit cylinder provides relief for the trippers of the pilot valve vented relief directly deliver the shaft of each end pump cartridge freely back to the tank. Another relief back control of the maximum pressure of the circuit. 310 shows a balanced vane pipe. Inlet chambers A and A1. 1 is your rotor. 2 is your drive shaft. 3 is the ring. And 4 is your vanes. And then outlet chambers would be B and B1. Alright, vane figure 311, the vane type, double the pump, head, end, pushing, ring, rotor, bushing, packing, body, bearing, flange, head, bushing, ring, rotor, bushing, shaft, gasket, flange, bearing, gasket, bushing. Alright, RA, and RA, pilot valve, directional control valve, remote unloading valve, double vane pump, relief valve, circuit using remote control unloading fluid, circuit using venting and relief valve. Show the RA, 2-pilot valve, direction control valve, venting type relief valve instead of remote control unloading valve, and then you over here would be the 4-way pilot valve, double vane pump, and relief valve. Unloading valve with a relief valve circuit that does the same do the same operation output. Both cartridges combined with the supply of fluid with a rapid advance for the portion of the cycle. One output of one circuit returned with the tank, and after reaching a certain point of the cycle, the other circuit complete with the advanced portion of the cycle. But both pump outputs combined with a rapid return. Two-stage pumps. Two-stage pumps consist of the two separate pumps assembled with the containment of one housing. The pump assembly connected with the flow of the outlet with directly internally with the inlet of the other single inlet outlet ports with the system connection. Construction pumps consist of a separate pump and the cartridge of the driven by the common drive shaft with contained within one housing. The divided valve is used to equalize the pressure load of each stage, correct with the minor flow differences from either cartridge. In operation, the developing the fluid flow with each of the cartridge, same signal with the pump. Figure 313 shows the fluid flow of the vane type two-stage pump with the oil reservoir, end of the pump with the inlet and passage for the outlet. First stage of the pump, cartridge of the passage for the pump drives body carries on the discharge from the stage. And the second stage outlet passage in second stage direct and oil outlet part of the pump of the passage U connected to both of the chambers of the inlet side of the either second stage pump. The ensures equal pressure. Both chambers and pressures are those imposed on the pump at external sources. Figure 313 shows the type two-stage pump. Shows ZA, B, Z, X, Y, and Z and W. It's a two-stage pump, inlet and outlet. A dividing valve with the figure 313 consists of the sliding positions A and B, with the position A exposed to the outlet pressure of the V, and the piston B exposed with the pressure between the stage of the passage W. The piston responsible for maintaining the pressure load with the first stage, with the equals to the half of the outlet pressure for the second stage pump. If the discharge from the first stage exceeds the volume that can be accepted at the second stage with the pressure provided for the curve of the passage W, the unbalanced force acting on piston B with the cover of the piston to move in such a manner that the excess flows piston B through passage Y with the inlet chamber of the first stage cartridge fluid throttling and crossing the piston B with the manner maintains pressure passage B. If the discharge first stage pump is less than volume required for the second, the stage pump will produce the pressure outcurve of the piston B with the unbalanced force on piston A. Causes the piston to move with the oil flow of the piston A with the inlet into passes X and W to replenish the second stage pump with the correct with the unbalanced condition of the passage Y and Z and Y. Fred means of a leakage around the piston to return to the inlet chamber. The first stage pump of the piston A and B always seek the position equally divided by the load between the two pump units. 3-8 piston pumps. The piston pumps are either the radial axle, radial with the radial piston pump, but the positions arranged like a wheel of spokes with a short cylindrical block of the drive shaft with the inside of the circular housing, rotated cylindrical block. The block turned with the stationary pinlet with the containment of the inlet and outlet port. Cylindrical block turned central figure 4 cylinders of the position with the following of the circling housing center block offset cylinder block of the center line with the amount of the eccentricity between the two with the determines of the piston stroke of the degree of the pump of the displacement. The control can be applied changing the housing location, thereby varying with the pump's delivery from the 0 to the maximum. Alright, the figure 314 shows a simplified radial piston pump. Show the rotary center line, cylinder block, center line, pintle, piston, rotor, cylinder block, case. Figure 315 shows the 9-position radial piston pump with a pump with an uneven number of pistons. No more than one piston is completely blocked in a pintle at one time, which reduces the flow of the pulsation. Each of the number of the piston space around the cylinder block to position can be blocked by a pintle. At the same time happens with a 3-position discharge at one time from the floor. At another time, the pulsation would occur with the flow of the pintle, cylinder block, the piston, rotor, and drive shaft constitute the main working parts of the pump. A pintle is a round bar that serves the stationary shaft of the round with the cylindrical block turned with the pintle shaft that has 4 holes bored with one end of the length, wide with 3 off of the part of its length. 2 holes serve as an intake with a tube with the discharge. 2 slides with the cut inside of the shaft with each of the slot connect with the tube of the length. Holes. The slots are in line with the position of the cylinder block assembled into the pintle. One of these shall provide with the path of the liquid, a path of the piston with the discharge holes bored, and a pintle with another slot connected with the two inlet hoses. Piston, when they are drawing liquid, the discharge hole will be connected with the appropriate fitting with the discharge line so that the liquid can be directed to the system. The other pair of holes is connected with the inlet line. Cylinder block. The cylinder block, figure 317, page 312 of the block on the middle of a hole bored through the center line with the pintle cylinder hole with the board with the equal distance part around the outside. The cylinder holes connect with the hole with the receiver of the pintle. Design differs. Some of the cylinders appear with an almost solid, while the other spoke-like cylinders radiating out from the center of the cylinder. Pintle holes over the actuator machines over the liquid are lots around the minimum piston. And figure 315 show the non-radial piston pump. Show the pintle in the middle, and then the case and slide block, rotor, cylinder, and piston. Pistons are manufactured different designs. See figure 318, page 312 of the diagram A. Show the piston small wheel rolled around with the inside of the curve of the rotor. Diagram B. Show the piston with the cylindrical edge top of the bears directly again with the reaction of the ring of the rotor. In the design, the piston goes back and forth with the cylinder, which will rotate with the axis of the top of the surface of the wear uniformly. Diagram C show the piston attached with the curved plate with the curved plates against with the slide around the inside surface of the rotor. Piston sides are accurately machined with the for cylinders. They are minimum loss liquid between the walls of the piston and with the cylinder. No provisions used for the piston ring that helps seals against the piston leaks. Rotors designed different with the pump of the rotor with the cylinder circular ring. Machine finished with the inside with against the piston bear with the rotor bears. Rotate side block, which can be shifted side to side with control of the piston length of the stroke. The slide block has two pairs of machine surface with extension exterior so that they can slide in tracks in the pump case. Figure 316 show the pintle of the radial positions in their port. Drive shaft is connected with the cylinder block and is driven into the outside source of the electrical motor. Axle piston pump. The axle piston pump with the piston stroke with the same direction on cylinder block. Center line with the axle piston pumps may be the inline or angle design and capacity of the pumps of the range from very low to very high with the pressure as high as 5,000 psi with the drive speed with the medium with the high with efficiency. A high pump with generally excellently durability. Petroleum oil fluids are you require with the pulsation delivery. All small with the medium frequency of the pumps. A quiet operation may have the growling whining depending on the condition, except for the inline pump, with which are compacted inside with the side of the pump and the heavy and bulk. Figure 317 shows the cylinder block with the radial piston pump, the inline pump with the inline pump position. Figure 319 with the diagram A with the drive shaft, the cylinder block with the same center line reciprocation piston caused by a swash plate with the piston run against the cylinder block, rotates the drive shaft. Turn with the cylinder block, carries the piston around the shaft of the piston, shoot the slide against the swash plate, held against the shoe plate with the swash plate. Again, will cover the cylinder to reciprocate on in their boards, and the point where the piston begins with the retract with the opening end of the bore slides over the inlet slot of the valve plate with the oil drawn into the bore. Somewhat less than half of the revolution with these solid areas of valve plate with the piston becomes fully retracted. The piston begins to extend, opening the cylinder barrel, moves down the outlet slot, and oil in forcing out of the pressure. 318 show the pistons of the radial position. Alright, displacement. Pump displacement depends on bore stroke with the piston, number of the piston, swash plate. Again, figure 319, diagram B. Determines the stroke variation change for the angle with a fixed angle unit with a swash plate. Stationary in the housing variable units in the mount with the yoke with the term of the pintle with the different control with attached with the pintle vary pump with the delivery of 0 with the maximum central position swash plate perpendicular with the cylinder. There is no piston reciprocation, no oil is pumped. Component with the major component with the typical fixed displacement inline pump with the housing bearing support with the drive shaft rotating group. A shaft seal with the valve plate. With the valve plate contains the inlet and outlet port function. The back cover of the rotating group consists of the cylinder blocks lined with the drive shaft with the cylindrical washer, spring 9 position shoes, swash plate, shoe plate with the group is assembled the spring place. Force the cylindrical box against the valve plate with the cylindrical washer. Alright, shows the inlet port, cylindrical bore, piston subassembly, swash plate, and drive shaft. An outlet port. Maximum swash plate, maximum displacement, decreasement swash plate, partial displacement, 0 swash placement, 0 displacement. Against the shoe plate, the action hold of the piston shoot against the swash plate, ensuring the piston will reciprocate with the cylinder trim of the swash plate stationary and fixed displacement design. Operation variable displacement inlet pump to operate with the same with a fixed angle, except with the swash plate with its round with a pivot to the yoke with a swung with a change of the plate angle with a change of the pump with the display with the yoke can be positioned manually screw or left with a compensate with the control with its position yoke automatically to maintain constant outlet pressure under the variable flow with the requirements of compensate with the control consists of the valve with the balance of the between with the spring and the system pressure with the spring loaded yoke and actuating piston with the control valve with the pump with the compensate with the control. Those produce the output over the only volume required for the maintain pressure preset pressure maximum must deliver only when the pressure is less than compensator setting. Wobble plate inline pump. The variation of the inlet piston pump in this for the design cylinder barrel does not turn with the plate wobbles and turn with the wobble bush of the push the piston in and out with the pumping chambers in the stationary cylinder valve. A wobble plate pump separates inlet outlet check valve required for each piston since the piston does not move past the port. Alright, bent axis axial piston pump with the angle or bent axis piston pump figure 320 of the piston rods are attached to the ball joint with the drive shaft flange for the universal link key for the cylindrical rocket shaft so that they rotate together with the offset angle. The cylinder barrel turns again with the store valve of the plate with the port. Connect the pumping action is the same as the inlet pump, but the angle offset will determine the pump displacement adjusted with the swash plate angle that determines the inline pump displacement. Fixed delivery pump with the angle is constant with the variable knob with the yoke mounted with the pointlet swing with the cylinder block. For your displacement flow direction can be reversed on appropriate controls. Pumping operation. The following paragraphs address some of the problems that could occur when the pump begins operating. Overloading. One of the risk of overloading dangerous success of the torque of the drive shaft of the torque and circular force of the object. With the increase of the pressure of the pump of the displacement will increase the torque of the shaft of the pump of the displacement pressure remains constant. Often in a given packet size, the higher of the gallons per minute pump will have the lower pressure rating than the lower gallons per minute pump. Sometimes a field version get more speed if the out of an actuator will cause the pump to be overloaded. You need to be a larger pump. Excessive speed. Running a pump too high of speed causes loss of lubrication, which can cause early failure with the need to deliver reach for the high drive speed with the pump's rating using a high displacement pump. Excess speed is also a risk of the damage of the cavitation. Cavitation occurs when the variable fluid does not fill the existing space and it often occurs the pump inlet condition but not right the supply with enough oil to keep the inlet fluid with the caution. Cavitation cover the metal to internal inlet to erode with a hydraulic oil determining or operate quicker. Cavitation occur with a too much resistant inlet line. If figure 320 shows a bent axis pumping piston pump shows the shaft, the universal link, piston rod, piston cylinder block, two inlet, two outlet, piston stroke. Alright, the reservoir's oil level is too far below the inlet. If the oil viscosity was too high, it will occur with it. There's a vacuum, even slight, and positive pressure in the inlet. The bad cavitating pump has oil bubbles exploding in the void. The only way to assure that the pump is not cavitating is to check the inlet with a vacuum gauge. To prevent cavitation, the inlet clean, free obstruction, use the correct length of the inlet lines, minimum bends. Another method is to charge the inlet, but the easily way to do this is flood or locating a reservoir above the pump inlet, and that is not possible. You can create a good inlet conditions and pressure reservoir. You can also become an auxiliary pump. Maintain supply of oil in that low pressure. You can use central figure pump with the most common. Use the pipe with the displacement gear pump with the pressure relief valve with the maintaining the discharge charging pressure. Operating pressure slow operation, no delivery noise are common operating problems in the pump. Pressure loss means that there's high leakage path within the system with a badly worn pump with the valve of the pressure loss pump loss with the efficient gradually actuator speed slows down the pump wherever the pressure loss is even more often caused by the leak somewhere in the system, such as a relief valve, cylinders, or motors. Slow operation, this is caused by the born pump with the partial oil leak system. Pressure will not drop however the load moves at all. If the load moves at all, there will be a horsepower still being used and is being converted into heat at a leakage point. To find this point, feel the component's unusual heat. No delivery. If the oil is not being pumped, could be assembled incorrectly, could be driven in the wrong direction, has not been primed. The reason for no priming is usually improper startup of the inlet, restriction of the oil level in the reservoir has been broken drive shaft. Noise. If you hear an unusual noise, shut down the pump immediately. Cavitation noise or restriction inlet line dry inlet filter to avoid dry speed. The air inlet shock also cause noise that severely damages the pump because it has enough lubrication. This occurs low oil reservoir, loose connection inlet with a leaking shaft sealed with no oil pumping starting. Noise could be caused by worn damaged parts but spread harmful particles through a system causing more damage and the operation continues. Chapter 4, Hydraulic Actuators.